All right. Hi, everybody. Julie, can you still see my screen?
Yep.
Okay, great. We're going to give it like 1 or 2 minutes, let people trickle in. They're coming in from the waiting room right now. Thanks, everybody, for being here tonight. All right. So let's go ahead and get started at 6:02. So once again, thanks everybody for being here. I'm going to try to get my energy up because I've been in the office all day and it's 6 o'clock now. But hi, good evening. My name is Kellen Damon. I work with the County Marin on the sustainability team. I'm joined by my colleague Julie Chu and Dana Armanino, who's going to be helping in the chat today, and Julie's going to be helping on tech, also with the sustainability team. And our presenter is Sean Armstrong, who we'll get to in a minute after some brief intro slides. So I'm going to pass it to Julie for webinar housekeeping.
Hey, everyone. So for today's agenda, so the program presentation will run from 6 p.m. to 7 p.m. We'll also have a session for Q&A from 7 p.m. to 7:30. Please enter any questions that you have into the Q&A box or the chat. You can upvote on questions from other attendees. And all attendee mics and cameras will be off. Use the chat box if you have any comments. CC is the live transcript or closed captioning, which you can use if you need to see captioning. And video recording, slides, and other materials will be sent out to you via email and will also be available on marinsustainability.org.
Awesome. Thanks, Julie. All right, so a little bit about the Marin County Sustainability Team. We are here and we work to promote healthy, safe, and sustainable communities while preserving Marin's unique environmental heritage. The team has developed programs to promote renewable energy, address climate change, encourage green building, and recognize green businesses. These policies and programs will ensure that the County Marin is healthy, vibrant, and sustainable for many generations in the future. We have a new website or a revamped website. I encourage you all to check that out. And we also post things on different socials you can see there. And we also have a newsletter. So if you want to, stay up to speed on informative webinars like this, I encourage you to sign up for our newsletter. That's a great way to be kept informed. So I'm going to talk briefly on Home Energy 101. We really encourage folks to do the low-hanging fruit first, and Sean might talk a little bit about this later. But really, it just makes the most economic sense to do things like change your light bulbs to LEDs, put in smart power strips, stuff of that nature. There's also a program that I'm going to share with you in a second where you can get those delivered to your home in the mail at no cost, which is awesome. And then as you're, kind of going down the list of making these home improvement upgrades, we encourage you to look at building shell upgrades like insulation and air sealing. That'll help your home be more comfortable no matter what season of the year it is. If it's really hot in the summer, really cold in the winter. And it'll also make sure that your mechanical equipment is running more efficiently and less wear and tear on your HVAC too. And then, the mechanical upgrades tend to be a larger cost, but HVAC, water heating, right now there's a lot of funding for switching out your gas appliances to efficient electric appliances, like heat pump water heaters and heat pump space heaters. And then from there, encourage windows, solar, battery backup, and electric vehicles. Sean's going to talk a little bit about vehicle grid charging today, which is awesome. So yeah, just wanted to put that plug in for home efficiency. One of the programs I mentioned that actually deliver, those no to low cost items right to your home is the Rising Sun Center for Opportunity Greenhouse Call program. They operate every summer, so you're gonna have to wait a little bit to sign up, but it's really a great program. They employ local college and high school age youth on their summer breaks to run the program, which is awesome. So there's that great job training component to it too. And there's a website, and again, I'm going to be sending out, all the slides from today to everybody who registered, so don't worry about writing anything down. And then home energy scores. So this is a great program if you're kind of looking for a place to get started. The way it works is somebody comes out to your home and does the home energy score, which is a walkthrough assessment. They'll tell you how efficient your house is on a 1 to 10 scale compared to other similar size homes. And each home score assessor will give you a custom recommendation on, what you can do to get started. What's the biggest bang for your buck and that sort of thing. Specialized, individualized for your home. So that's great. And there's also a $200 rebate available for each home score done in the Bay Area through the Bay Rent program. I mentioned at the top that we just redid our website and we created an electrification info hub. So what that is basically we wanted to make a one-stop shop for all of your electrification needs. We have information on our rebate program, Electrify Marin, as well as other rebate programs. I'm just gonna check the chat to make sure. Okay, I just wanted to make sure no one was like, hey, I can't hear you. So yeah, that's a great place to get started. We also have information on concierge and assistance programs because there are a lot of different rebates out there with different requirements and places that you have to submit information. So basically there are these concierge services that kind of help do that work for you, and we have information on those at our website as well. And last but not least, if I can move my slide. Just some additional resources on indoor air quality and resiliency. We have a page on induction cooking, which is really important to get those fumes out of your house. We have a solar and battery backup page, and I want to make a plug for Fire Safe Marin. They offer some great resources on home hardening. The first time we actually did this solar and battery webinar was right after one of those major PSPS events, and we saw a huge uptake in generator permits, and there's a lot of interest in this webinar as well because people are looking into battery storage. But FireSafe Marin provides a lot of great info on home hardening, including tips and project ideas, and they have grant opportunities for getting your home ready for fire season. So with that, I'm going to pass it off to Sean, and I'm going to go ahead and stop sharing.
Hey, thanks so much, Kellen. So my friends, thank you so much for taking personal action here, or at least anticipating it. Personal leadership is the only kind, in my opinion. So home solar and batteries in Marin County. First, I'll just say hi, introduce myself. I grew up on a farm in Wisconsin. Wisconsin is one of the leaders in home renewable energy. The Midwest Renewable Energy Fair was the world's largest until the mid-2000s. So I was raised in that milieu, and I came here to Northern California to study specifically at the leading university in the nation on home renewable energy, which was Humboldt State University at the time. Now Cal Poly Humboldt being recognized for its leadership. So I got a job in 2005, and under the Bush administration, we innovated the first zero net energy housing in the nation. It was low-income senior housing, both in Arcata for apartments, the first zero net energy apartments in the United States, and then the first zero net energy subdivision in Fort Bragg, up the road from y'all. In 2011, then I left Danco's, the Great Recession, and so I got laid off. But then I started Redwood Energy. And there you can see the projects that I got funded in 2008 and 2009 got constructed. You see my little look, we did it. And I've had a successful career essentially doing zero net energy, affordable housing, terrific. Felt like I was making a difference. And then my mother-in-law died in the Tubbs fire in Santa Rosa in 2017, which really rocked my whole family, as you can imagine. And so the next year I hired lawyers to try to figure out how to ban gas from cities. I'd been a city activist. I'd sit on city committees and commissions and chaired committee, et cetera, and written local ordinances for the city of Arcata. So I knew we could do it. I knew that cities had these powers, police powers. And then you saw under the Trump administration, the first time we had a city ban gas once every 2 weeks for a year and a half. So I really feel like regardless of our national politics, California has always been a sort of a nation unto itself. And so I'm not so worried, just so you know. I mean, I am worried, but not so worried. I was just texting with one of my former staff who was like literally drinking himself into a blackout drunk situation because he's so upset. He's like, just had surgery, and I'm talking with him like, hey, no, calm down. 4 years, we'll get through this. And for those of you who are happy about Trump's election, congratulations. Okay, so people in rural America, like where I grew up, they built the first 1 million microgrids starting in the 1920s. About 90% of rural Americans did not have electricity in the 1920s. It wasn't until the federal government's Rural Electrification Administration in 1934 that 60% of America's landmass got electrified. And it was just people, just neighbors putting up their own poles with loans from the federal government that were forgiven then once they did all the work. We're going to jump ahead to the 1970s. Marijuana cultivation in Humboldt County, Lake County, Trinity County, and Mendocino County. Way far off the grid was how solar was kept alive. Other than NASA, NASA was the only customer for solar from 1958 until the 1970s when it started to become available through ARCO to get your solar panels. So this is a gorgeous facility that closed recently, kind of closed because of our success. The mainstreaming of renewable energy meant that the Real Good Solar Living Center didn't have enough of a purpose to be a big business. But I used to go to the events there back when off-grid was the only option in the 1990s, and I was in college. We didn't even get PG&E to back down until 2000, and finally solar was allowed to be connected to the grid. 1998 is when microgrids, these off-grid facilities went into space. That's finally we got the International Space Center. NASA launched it up, and of course, completely solar powered. Uses heat pumps, by the way, to balance the heating and the cooling of the Space Center up there, where it sort of essentially pulls heat from one side of the building, you might think of it, and puts it into the other side of the building. And now we have things like microgrid yachts. These are completely solar and battery powered, no fossil fuels. You can go across the Atlantic Ocean or the Pacific Ocean 50 to 100 miles a day off the solar array that's on the roof and the batteries that then charge the engines. You can see in the upper left-hand corner, that is one of the bedrooms. Lower left-hand corner, that's a TV screen that's hiding the kitchen. It's like a commercial kitchen, essentially, because there's seating for 12, and this is a 4-story tall building when you go underneath. It's quite a boat. On either side of the boat, pardon me, on one side out drops, I'm not joking, a submersible submarine, an electric submarine from U-Boat Works, the Nemo 2. And then the other side drops out 1 or 2 of the Tega Orcas, the electric jet skis. They're like 0 to 60 in 3 to 4 seconds on the water, no sound. So you can come right up on the wall on the whales or the dolphins and just be right there, no noise. Here we have in Miami, solar and battery powered floating mansions. This one also collects its rainwater, and I'm not clear if it treats its sewage. I doubt that. I know how difficult it is to treat sewage, but I couldn't find the technical details on it, but I do know that it collects rainwater. So microgrid, just solar and batteries. This is where we are right now. And then this is a project that I've been accumulating a lot of grant funds for, and it's starting construction next June. And this is 131 apartments in Petaluma. And this will be a 95% off grid. We're putting in enough solar, about 9 kilowatts per apartment, and about 2 Tesla power walls of equivalent per apartment, but it's a combined system so that if some people are using less and other people are using more, they all get what they need as opposed to having it be individualized. So we got grant funding, research grant funding to demonstrate that we only need the grid for maybe 3 weeks out of the 52 weeks a year for a little bit of the time. And otherwise, that's just winter storms is what I'm talking about, like 3 or 4, sometimes 5-day long storms. At about day 3 or 4, this has run out of electricity in the batteries and the solar, which can produce a little bit in cloudy weather. So it'll start trickling electricity in from the grid. And now, if you are not wealthy enough to have your own houseboat, then this is your alternative. This is for you in your little houseboat, your house. So if you're trying to stay indefinitely, like winter or summer, you're trying to stay indefinitely safe. There's a big earthquake, there's a big natural disaster, etc. what you do is you'd get a solar array that is, as you see here, the Goal Ranger 300. This is just 300 watts of solar, not a huge amount. This is also the amount of solar that was on the house, the demonstration house I learned from on campus at Humboldt. We only had a 300-watt solar array at the time that we were running off grid. So with that solar array and that battery there, you can run winter, summer, for days, I mean, like weeks, for years. This is indefinite. If you have the solar array and this battery and these very efficient devices here, so an electric blanket to keep you warm, a portable fridge and freezer, it's well insulated. You have a laptop and a cell phone, of course, charging those. Your personal evaporative cooler, it's just a small thing that misses you cool air. You'd be able to cook food here in that roasting pan. There's a lot of devices that are really energy efficient that are designed to run on cars and RVs. And then lighting, you'd have it. You can stay warm, you can stay cool, you can stay fed, you can stay in touch, you can do lighting at night. $3,500, 1 to 2 people could live this way. But I'm here to talk more just about like, solar and battery on people's homes. I did want to give you a little bit of an expansive view of both how amazing it can be and how frugal you can be. So you just saw that sort of accordion expansion and contraction there. Now let's dig into people's homes. And I do want to encourage you to ask questions along the way. And John Snell, you asked, what rebates and tax incentives are available for retired electricians and engineers? The same ones that are available to everybody else. And so it doesn't matter if you have a license or not, although that matters for building permit purposes, but you have 30% tax credits from the federal government for your solar array and for your battery. Since we're talking about solar and battery in this presentation, simple enough. If you're putting in heat pumps, there's a few $1,000s there for heat pumps and et cetera, but that's a different talk. Tonight, I'm just saying it's 30% off. If it's low-income housing, like what I was just showing you in Petaluma, that's low-income family housing, that microgrid, then you get 50% off. And that is federal statute, not something that an administration can change. Just federal statute. Laws, So then here we have, I know I'm just going to say, ask questions. I'll try to answer them if it's appropriate. So how much does it cost to install solar panels? Lots of different factors. And one of the things you'd ask is like, well, how much electricity do you want to generate for your house? Because larger solar arrays can sometimes be disproportionately expensive. I'm going to show you how to avoid that. But nonetheless, where you live, up in Arcata, where I live, we get 1,100 kilowatt hours, which is the amount of electricity, 1,100 kilowatt hours per year per kilowatt of solar panels. And a kilowatt is about 2 sheets of plywood worth of solar panels. Kilowatt is the amount of electricity that it's producing when it's noon on a sunny day. The panels are rated in terms of their instantaneous maximum power. Whereas I'm trying to explain to you, essentially, over the course of a year, 1 kilowatt in Arcata makes 1,100 kilowatt hours. Down where you live in Marin, it's 1,450 kilowatt hours per year per kilowatt. That's nice, like an extra 20, 25% of electricity just because of where you live. And if you were down in Los Angeles, it'd be about 1,600 to 1,700 kilowatt hours per kilowatt. And over in Palm Springs, it's 1,850 kilowatt hours per year for the same kilowatt of solar panels. So climate makes a difference. And similarly, if you have shade up on the roof, if you're facing your panels north, which works, you lose maybe 30% of the electricity, but during the summertime, the sun is so high in the sky that even north-facing panels get direct sunlight. So, and that's when the sun is intense. So it's a 30% reduction. Now, I'm going to get into home energy storage in a minute, but that also ties into it. Here's a different way of asking the question. Residences on the upper left-hand corner, I realize it's a little busy, so just focus on the green in the upper left-hand corner. 1 kilowatt costs $4,200. A kilowatt has 1,000 watts in it, so 1 watt is $4.20, and that's what these are rated in. You see $4.20, $3.20, etc. So homes are the most expensive. Apartment complexes, like the Petaluma one, that's what we see is $2.20 or $2,200 a kilowatt. dramatic difference, almost half as expensive to put it into a big apartment complex and carports than it is to put on individual homes. Nonetheless, I'm going to show you, it makes financial sense. On the lower right-hand side, you might be asking, oh, wow, a mosquito. Who would not guess that up here? I'm in Pittsburgh and it's cold outside. Okay, I'm in Philadelphia, pardon me. I'm here for a green build conference to present. So the lower right-hand corner, look where it says residential, and there's 3 different lines there. So the bold line, that's the cost of labor and materials. And you can see how the straight, like bold black line, green line, I should say, has gone down since 2000, but the dotted line, the second one there, that's the one that's for the module price. That's the solar panels themselves, radical reduction. In 2000, say, a solar panel would cost in the range of $6 to $8 a watt just to purchase it, not install it, just to purchase it, or differently put $6,000, $8,000 a kilowatt just to have the panels. Now, instead of it being, we would say $6 a watt, we'll use that as an easy metric, $6 a watt or $8 a watt, it's 15 cents now for a solar panel watt, or $1,500 a kilowatt. It's, oh, no, pardon me, $150. It's ridiculously cheap. The price has fallen down so low that really, and the same thing with the inverters, where that's the last of those little open circles. Inverters have dropped by more than half. The cost of the panels has dropped by far more than tenfold, 15-fold, radical reductions. It's just labor and the racking materials and building permits and getting people mobilized to the site. That's the stuff that hasn't been dramatically reduced. So it goes. Now, batteries in the lower left-hand corner, Berkeley Lab, this is the national laboratory that's in Berkeley Livermore National Laboratory. Berkeley Lab notices, they said batteries are $900 a kilowatt hour. That's a unit of electricity, a certain amount that's stored, a kilowatt hour. So with that, basic numbers that you're going to spend maybe roughly $4,200 a kilowatt up on your roof. And it could be less. I mean, getting 3 bids is the way to always do any construction project that's over a few $100. Like if you're spending thousands of dollars, go get a second opinion, just like you would with a doctor. If you're spending a $10,000, get a third opinion from your doctor, solar doctor. Now, payback. This assumes that you're putting in a relatively small array, 3 kilowatts. The average solar array right now is about 4.5. So this is, a third reduction. A 3 kilowatt array, that's an amount of electricity when it's producing during the day that you could self-consume that by running your air conditioner during the day. So when you get home, your house is nice and cool instead of running it when the sun has already gone down and you don't have electricity being produced. Charging your car during the day, charging your water heater, heat pump water heater, put it on a schedule, run it, get it nice and hot during the day. So if you self-consume your solar, you are essentially being paid the same amount of money for your solar electricity as you would pay. You're not consuming it, and therefore you can sort of think of it being paid for that amount. So let's say you put a 3 kilowatt solar array at $4,200 a kilowatt. I'm going from left to right up on the top in the green. The size of the array is 3 kilowatts, so the total cost is $12,600. There's a 30% tax credit, so your total cost is $8,820. Now the energy produced in blue, you see it's 1,450 kilowatt hours per kilowatt. So you have 3 kilowatts, so be a total of 4,350 kilowatt hours. And that's about 12 kilowatt hours a day. Cool? So now in the lower left-hand corner, you get your final cost of 8,820. Right now, today, electricity during the day is about 38 cents a kilowatt hour. It goes up, it has gone up 20% a year for the last 5 years. PG&E has not been audited by our CPUC in 9 years. All of the things they're charging us have not been audited. And now the CPUC, which is fully under the control of our governor, and the number one donor to our governor, wait for it, the utilities, PG&E, SoCal Edison, SoCal Gas, number one donor. So his Public Utilities Commission has not audited our outrageously highest in the nation electricity costs. No place more expensive now than San Diego at $1 kilowatt hour. Oh my God. Okay, so I'm just pointing out that today it's 30 cents, 38 cents a kilowatt hour, but next year it should be another 10 to 20% higher because that's what we've been dealing with for years now. So a break-even point is after you produce 23,211 kilowatt hours. In other words, in about 5 years, that's at the point where you would start making money. 5.3 years, now you're in the black, so to speak. The solar array, of course, is warranted for 25 years. The panels themselves, you can get 40-year warranties on now. So 5 years is just the beginning. Now, what if you put a battery in? Now I'm going to add the cost of the battery, and I'm going to assume that the electricity is a little more valuable because the batteries work at night. And electricity prices go up to 54 cents a kilowatt hour. So on the lower left-hand side, we're going to see here that now the price plus the battery is $10,320 for this Sun Gold 5.12 kilowatt hour battery. You need to basically wait 10 and a half years. Now, this, of course, is assuming that electricity prices don't change. This is a very simple math. I just told you that they're likely to go up 10 to 20% every year until we get a different governor. Someone who actually requires auditing and tries to control costs, as opposed to just taking money from his number one donors to look the other way. So 10 years is a conservative estimate, but that's what you do is you put up a modest-sized solar array, self-consumed during the day, put some of that electricity into a battery and produce it at night when electricity prices go up even higher. If there's any questions, I'm going to just look in the chat on that because I realize it's like for a lot of you, like this is the point. How long does it take? And I'm saying like 5 years to 10 years. A sampling of the inverters and the solar panels. Now I'm just looking at some comments here. William, you asked, is there a concern regarding roof leaks with solar panels? No. So far, I've never heard of that being a problem. Some of the panels go on with no perforations, nothing, but other ones, they go on with really significant flashing. They get slid underneath your shingles. And so it's not just like they're poking holes in your shingles. The whole thing gets slid underneath shingles and surrounded by shingles, and it becomes continuous with your roof. So generally not a problem. I mean, this has been a huge amount of work has gone into preventing that. Miyoko, I apologize if that's not how I pronounce your name. You say, I have solar already, but you would like to know how to get a backup battery such as Tesla's Powerwall, but wondering if there's an alternative to that and what the most cost-effective systems are. I live in West Marin where we have outages several times each winter. Well, the battery I was just showing you there, pardon me, that was Sun Gold. LG is an excellent brand. Tesla, of course, is an excellent brand. And connecting it, you should, like I said, have a couple of solar contractors come out. Frequently, they're committed to a certain brand. Batteries are like buying a home computer. And so you're buying it from someone who's a Mac person or an IBM person. They're not just a solar contractor. They are committed to a certain package of technology. So be aware of that when you're working. You say your roof is leaking from the panel installation. I don't have power yet. They're coming to look at it tomorrow. What should I look about for the work? That's distressing to hear. You're literally the first person I've ever talked with is having a leak. And I've been installing solar myself since 1996. So flashing. I mean, leaks are a consequence of them not thinking about how water moves and not doing a good enough job getting the sticky tar stuff to actually attach. So not knowing exactly what the situation on the roof is, the fundamental is that you keep water out with sticky stuff and getting it so that there's shingles covering it and the water goes down. Don't know. Yeah, sorry about that. Kirk, you say, well, I provide specifications like UL ratings required for the batteries. All the batteries that are for sale that can be hooked up to California's grid are ridiculously regulated. PG&E has a very short list of inverters that are allowed to go up, similarly with the batteries. So it's way beyond UL listings. If you're legally allowed to get that battery onto PG&E's grid, it's a high quality battery. This is not something coming off a boat from some no name in China. There's a short list of companies. Installation cost for the battery. Tom, the installation cost, what we're seeing is total, all in, is $900 a kilowatt hour is what you're generally finding out there as an average. You are living in one of the most expensive places in the whole nation to install solar or install anything. The North Bay and the South Bay are the most expensive markets in the nation for constructing anything, just so you know. So your battery price could be higher than $900 a kilowatt hour installed, but you should really advocate for less. Can excess battery storage be sold back to PG&E? Yes. Starting a few years ago, PG&E also was encouraging people to sign up for their virtual power plants. They pay you a lot of money, like $2 a kilowatt hour during the summertime, during peak hours to use your battery to support the grid. And that's why we had no blackouts this last summer, because home batteries had more than tripled in just a couple of years and they were put to work. And that was what, even though we had much higher energy consumption this year than we did previously, because every year is a hotter summer than any year previous, we didn't have outages this year because of home batteries. Yes, you can definitely sell it back. Can you put panels on a flat membrane type of roof? Yes. You might use the ballasted type that are weighted down without penetrating. That's what I commonly see on flat roofs. John, you say, what affordable solar PV panels also serve as a waterproof roof, replacing the shingles or a metal roof? I don't encourage people to go that route. For years now, people have been trying to make roofing shingles, and Tesla took a whack at it and did not succeed, with their Solar City solar panels. It's hard to replace them. If there's any maintenance issue, you're taking apart your whole roof. You're not just popping off some panels and racking. It's a much more significant investment. And so 95+% of the market is in individual panels that get put on racks. And there's almost no market really for roofs that are shingles. So I don't have a good suggestion. Sorry about that. Diane, you say our home is modular and doesn't have rafters that are strong enough for solar. Yes, I'm going to show you later a lot of different options for places besides a roof to put it. Is ballasted mounting allowed on flat roofs in Marin? To my knowledge, I've seen them go on in apartment complexes a bunch. I don't think it's a building permit issue at all. Vicky, you say you're interested in learning about solar panels that would charge a battery that could be used during home electricity outages. This is what you're seeing right here on the screen. You're interested in battery backup without solar. What's your best option? Probably Tesla or LG. Those would be the two big ones out there. I've been installing solar. Do I have a company? It's called Redwood Energy. We don't install solar. I have always volunteered. I've actually worked for an installer for about a year, but otherwise I've just helped out friends and been very involved. Is there a case for just a battery with no solar panels? Certainly is. Yes. Because you're going to be able to sell electricity in the evening. You live on a houseboat in Sausalito. How nice. Are there solar companies that install? You bet. Sunlight and Power in Berkeley is probably the biggest, fanciest of the solar installers in the Bay Area. And I might suggest that you call Sunlight and Power for your situation. Yes, I will email the presentation. All right. Back to the fun.
And Sean, just a heads up
Yes.
too, there's some questions in the Q&A, but yeah, maybe let's
I'll stop
later.
and answer as best I can.
Yeah, they're coming in on both you're
Okay.
getting double barreled right now.
Good. I'm glad you guys are asking questions. We're going to try to answer them all. So on this screen here, you can see on the left-hand side is what's called a microinverter. Very common now that there's a small inverter underneath each panel. They are also warranted for 25 years. No good reason not to use them. Then there's single-phase inverters like this one from Solar Edge. Generally, they only have warranties for 10 to 15 years. They're not as long of a warranty. But there are reasons to use them, and people frequently do. Okay, on the right-hand side, these are just three of many, many, many different solar panel companies, but these are three of the big names: Canadian Solar, SunPower, and J Solar. SunPower just went out of business a couple months ago and got bought out by a new company. They're still offering warranties and such on their materials, but you should know they went through a bad spell. Here is SunPower with their 40-year warranty. Like I said, the panels are still for sale. They're owned by a different company now, but they're worth noting that 23% efficient. When I was starting my career back in the 1990s, panels were 12, 13, and 14% efficient at best. So you can see how science has really been pushing it hard. And right now there are panels that are 28% and 32% efficient that are being used in very expensive functions like, space stations That's where you'll see like 30+% efficiency because, launching it into space, it better be efficient and last for a very long time. Now, this is some sizing information. Now, if you have a 1,200 square foot house, small house, few people living in it, should be about 4 kilowatts. This is an average. If you have a larger house, 2,000 square feet, you're not frugal. You have a swimming pool in the backyard, you're living a good life. You might put up an 8 kilowatt array. Every car, as you drive it 12,000 miles a year, roughly on average, takes 2 kilowatts of solar up on the roof. So if you have an EV, you'd put 2 kilowatts up and that would offset your demand. Ideally, you would charge the car while the sunshine is out, particularly on weekends. I'm going to go back to the chat and the Q&A, see if I see there's a bunch of questions in the Q&A here. That's fair. Okay, so Larry Hokie, you said you read that the president plans to pull unallocated funds in the IRA. Do you anticipate we'll lose the 30% federal tax credit? No, the IRA is not related to the 30% to 50% tax credits. And the president is still obligated by a 1974 law to enact and enforce all laws and does not have discretion to not spend money. That's different from the kind of monkey work that he might try, but it's illegal. It's a very straightforward law. The president is there to execute laws, not to make them. Anonymous, you insulated your house a few years back and your electricity bill is less than $100 a month. Congratulations. Why should I spend the money I'm putting in solar and a battery backup? I don't know if you should. That's nice and frugal. But if you were to put up a small amount of solar, it would still reduce your bills cost effectively and get you, like a 5-year payback. So it depends on if you want to spend the money that way. And of course, you might do it for environmental reasons or et cetera, but just talking money. What is the going cost, including incentives, to put in solar and battery backup for a 2,000 square foot house? You can't really do the metric that easily that way because who knows what size solar array you'd be putting in. But the average solar array out there is 4.5 kilowatts. So let's just say you did the average. We just established that would be about $16,000 before the tax credits. And that would be about $11,000 after tax credits for the solar array. The battery, I don't think I can do the mental math on that one. I apologize, but I think you should put a budget of about 15 grand on your house if that's what you're trying to do, solar plus a battery. Carol, you've hired a nightmare company. They've been popping holes in your roof and making it leak, but they've failed the fire inspection. What are you going to do when they come out? How do you make sure they're doing this correctly? Boy, I'm sorry. Having a third party come out, a roofing expert, so any roofing company, you have them come out and you inspect the flashing. That's the name for the water sealing, the way that they insert the things that mount onto your roof, the racking system that attach to your roof, that be flashed and gooped. And so you'd have a roofing company come out and inspect. Dennis, you have a 7.5 kilowatt system, now 20 years old. Congratulations. Had to go on NEM 3, so your bill doubled. I'm so sorry to hear that. Looking to get a battery. What do I suggest? I suggested LG and Tesla. Those are the two brands that I know do go well. How much maintenance is needed a year? Really, none. You don't need to wash solar panels ever. There's a great analysis of this. It was done by a big affordable housing company that I worked with. There's an early zero net energy project, and their panels got filthy from a construction site next door, like just dirt covered them. You couldn't see the solar panels, it was just dirt. After they washed them for a couple $1,000s, this is a whole apartment complex of them, right? After they washed them, they discovered only a 6% increase. This is because dirt has in some ways, it actually makes the panels more efficient by cooling them off on a hot, sunny day. And the dirt doesn't necessarily obscure as much sunshine as you think. It's a thin coating. So you don't need to maintain them much. I've had mine for more than 10 years now, and they're starting to grow lichens where I am, so I want to scrape those off. Anonymous asks, won't a lot of people with smaller electrical panels need to upgrade their panels to allow them to accept solar? No, I'm going to get into that, but basically 4 kilowatts and less, that fits on a 100 amp panel. 200 amp panel that you likely have that fits up to 8 kilowatts without doing anything tricky. So generally, you don't need to upgrade your panel. Granted, electricians are constantly trying to sell you that work as a favor to you. As a favor, they'll charge you $3,000 to $30,000. Thanks a lot for the favor. So I'm trying to show you today how not to do that. You're anonymous, you're upgrading an off-grid system. Do you need a county permit? Is it hard to get a county permit? Can I get a rebate even if I don't get a permit? Permits are not required for rebates, for tax credits. This is not a rebate. There are no rebates, meaning cash. There are tax credits, and tax credits do not require a building permit. Is it hard to get a county building permit? This is an electrical building permit. It's not hard. I mean, it's not nothing, but not hard. Okay, so I'm going to show you a few different ways to do solar panels: string inverters, power optimizers, and microinverters. All right, string inverters are the old school way of doing it. I grew up with those. And what happens here, look on the lower left-hand side. You can see how there's a tree that's shading just one of the panels, and that cuts its production by 50%, but also the other unshaded panels. The idea is like if you have a horse in a 12-horse carriage, the slowest horse is not getting dragged. It's just going to slow all the rest of the horses down. So don't recommend string inverters. It's the old way of doing it. I do recommend power optimizers or microinverters. Both of these things are a box that sits underneath the solar panels. Power optimizers, here in the same circumstance, you can see now this shaded panel is being optimized. So the previous one you saw was 50% reduction. This one is now a 35% reduction to 65% left. And the other two panels are producing 100%. So DC optimizers go with one of those big boxes, an inverter that looks like this, but not set up like this, but looks like this, a big box down there fits with power optimizers. And you have DC wiring, not AC wiring like you have in the walls. DC wiring is what this does. So each panel provides the maximum power. It is more maintenance. The central inverters, particularly those big boxes here, those just don't last as long. So that's why people have moved on to microinverters, which this shaded panel is not producing 65%. It's back down to 50%, but the other two panels are at 100%. So you can see how a microinverter isn't quite as good as a power optimizer, but you can track each panel's performance. This is one of the things I like the best about it. You can get every month, you can get a readout on how your panels are doing, panel by panel. And so you can figure out if a microinverter is popped. They say there's disadvantages because there's more wiring, but basically it's very minor amounts of additional wiring. The two systems pretty much cost the exact same. So I would recommend microinverters because they have longer warranties and they're easier to track and maintain. However, this central inverter, right, which would go with the power optimizer strategy, this is neat. This is doing something that microinverters can't do, at least not yet. It's clipping. Clipping means that you might put in a solar array that at maximum can produce 8 kilowatts, but your electrical line to your house can only accept 4 kilowatts of that. So there are an hour or two a day in which this thing would have to clip off that extra production. And it's mostly going to be the hottest, the sunniest parts of the summer. So people will put in clipping inverters so that they can maintain the service line to their house, the copper wire that the utility delivers to your house. And while you do reduce the amount of power that can come out, it can still work out where maybe you reduce the amount of power your panels can produce by like 10% or 20% or something like that. But still, the solar array was cheap, you might argue, or you really wanted that amount of solar for other reasons. Just go down a list. Clipping inverters are an option to prevent you from having to go to a larger service to your house, even though you're putting up a big solar array, because 4 kilowatts fits on a 100 amp service, 8 kilowatts fits on a 200 amp service. What if you had 10 kilowatts on a 200 amp service? The clipping inverter would do the trick. Now I'm going to go up to some questions because you can see in the chat there's a bunch. What is the higher maintenance cost on microinverters, you ask? They're a slightly fancier piece of equipment than a power optimizer. So as you replace them, they have a slightly higher cost. Granted, it's on a 25-year warranty. So I don't think it's an importantly different thing. Greg, you asked, with a Tesla 3 battery pack, any concern with attaching a lithium battery to your home, i.e. explosion potential? No, cars explode a lot more than gas cars, I mean to say, explode a lot more in people's garages than electric cars or electric batteries, which is to say almost never. You just never hear about someone's gas car exploding, and yet statistically, they're more likely to blow up and do cause fires more often. I've been in a car that was on fire once, by the way, a gas car, and the guy pulled over. I was hitchhiking, and he went into a Carl's Jr., took someone's drink off their table and just dumped it onto the engine to put out the fire. And I got the hell out of there. I wasn't hitchhiking with that guy anymore. But real, gas cars catch on fire. John, you say, please talk about gluing water piping behind the solar panels for solar radiant. No, I'm not going to encourage anyone here to put solar thermal on the roof. What that should be is a heat pump water heater. That is a solar thermal collector. It collects all of its heat from the environment, and then you don't have a way more expensive solution called solar thermal that doesn't work in the wintertime. Heat pump water heaters collect solar thermal energy all winter long, even if it's negative 30 degrees Fahrenheit outside up in Truckee or something. You can always get a heat pump solar thermal collector to work. Solar panels up on the roof are yesterday's technology. That was a good idea in the 90s. It was an okay idea in the 2000s. It stopped being a good idea around 2015. And they also break within 8 years. They're terrible on maintenance. I don't know, Seth, about the eVault Life PO4 battery. I haven't heard of it before. Tom, you're wondering about NEM differences, when we might be forced to switch to another level. I think that our governor, who has been allowing every one of his agencies to attack rooftop solar, I think they've done every bit of harm they can do. I mean, the rules that have come out, like in San Diego, you get paid nothing for your solar. I mean, literally nothing. No, not like 1 cent. I mean, nothing for your solar that you export. How can you get worse than nothing? Okay, I'll go back here. Some examples. So Perlita, this is just a cute house. I just wanted you to see. It was a house in Los Angeles that I helped out with. Their 2,000 square foot home is zero net energy, 100% production with a 4 kilowatt array, 2,000 square foot house. It's very well insulated, but that's about all you could say about it. Otherwise, it's just sort of a normal house, just very well insulated. So it cut its air conditioning load and cut its winter heating load, which is great, but 4 kilowatts. Here, this is a house in New Hampshire, super cold, right? So 7.5 kilowatt solar array. The house is about 2,000 square feet. They got rid of their old boiler, put in a ground source heat pump, got lots of insulation everywhere. Good on them. Now, there was someone asking earlier about where do you put solar if you don't have a roof that's appropriate for it? Like maybe your roof is built with 2x4s that are overspanned, and you can definitely see your roof is already sagging because they didn't span the 2x4s close enough. That's my ex-father-in-law's roof example. What you do is you put it on the side of the house, just going from left to right. This is a solar awning, totally affordable. It's just some 2x4s you see there hung on the wall. Here you see something a little bit pricier. That's like a solar shade carport for your car. Here's another one, just some metal carports up there. So you basically build a new roof. Here you have, that's a solar shade structure. I mean, it's getting so hot now that it actually makes sense to farm with solar panels over tomatoes so they don't get burnt. This is the thing, hot sunny days. You also see this with grapes. You'll see this with raspberries. I have friends who have shade awnings over their farm just so that they don't burn their various fruits. So putting panels up, they still let light through. You have what's called a bifacial panel. It doesn't have sticky white stuff on the back of it, the melamine plastic layer. So no plastic on the back. The sun comes through in between the solar cells. Here, this is kind of a nice pergola carport or an arbor. You can call it what you want. But it's just fancy. You can see people have tables and things outside. So the idea is you can do a wall mount or a ground mount. If you're not doing a roof mount, you could do it on your walls or you could do it on the ground. And I didn't even show ones that are just kind of sit on the ground. You see those around schools frequently. They'll just pound pieces of metal into the ground, 5, 8 feet deep. and then they'll put panels on the racking above it, and they didn't pour concrete, they just pounded them into the dirt. Now, this is important. Avoid rewiring your service when installing solar. It's important because if you get that, this is the blue wire, right? Here, this is one of my staff. Emily Higby made this illustration. It's very helpful to see that the blue wire, the utility will pay for that blue wire. But they charge everyone on their rates, so it's not free. The part that you will pay for, though, you will pay at least $3,000 to your electrician, but it could be up to $30,000 because some installations are more expensive where if you have to get a new wire, it actually means you have to upsize the bucket transformer on the pole route nearby. It doesn't happen often, but I'm helping out a client who has a $30,000 bill coming at them because they're the ones who are triggering the service upgrade and then also the transformer upgrade. You don't want that problem because it also will take you at least 2 months. That's as fast as it can humanly go to get a new blue wire delivered to your house, a thicker copper wire so that you can deliver more electricity to your house and also export more electricity from your house. And it could take 2 years. Huge delays. PG&E is terrible at showing up on time, anywhere remotely on time. I mean, I could go on and 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 on about stories. Just the important thing is that you don't need to. I showed you how to use a clipping inverter. I mentioned to you that like 4 kilowatts is really all most people need. And 4 kilowatts fits on an old-fashioned 100 amp service to your house. Most homes in California have been moving to 200 amps over the last 20 so years now. And 200 amps can host 8 kilowatts without any tricks. And 100 amps can host 4 kilowatts without any tricks. So just stay within your service budget. It is cheap and easy and won't take any time. And if an electrician is proposing a service upgrade, firmly say that you do not want one, then you want them to figure out a different solution. They constantly upsell people on something they don't need and make a ton of money off of it, saying they're doing you a favor. So to make this a little, on the left-hand side, this is a cartoon of your breaker panel. Like if you're opening up that metal box, this is a cartoon of that. So the things that are in light blue are just code minimum requirements. Then in light green, these are all examples of maybe some more power efficiency so you could stay on your 100 amp service. And one of those, lower left-hand corner, you see it says 240, that's the voltage. And it says 16, that's the amperage. If you multiply those two numbers together, 16 times 240, let's see, anyone do this for me? Or if I can, yeah, I can't do it. Anyway, it should get you about 4.2 kilowatts or 4,200 watts. That's 4.2 kilowatts. So what I'm showing you here is that this 2,000 square foot home, you can meet all the loads on 100 amps, all electric. That's the first point, is that you can make an all electric home up to about 3,600 square feet. You can have an all electric home on 100 amp service, the old fashioned since 1962 100 amp service line. If you put up a 4 kilowatt solar array, just walk away. Good job. You know, that fits in your circuit breaker panel. But more than that 4 kilowatts, now you've broken rules and you have to have a 200 amp service and so it goes, you know. So 4 kilowatts is a good magic number. There are technologies that are coming to prevent you from having to plug your solar array into the circuit breaker panel, which is this limitation. The circuit breaker panel has only so much capacity itself as this little box of plastic and tiny pieces of metal. However, the meter, that's taking electricity straight from your service line. All 100 amps flows through your meter, and it's designed to be able to handle that amount of power. So now they're making what are called meter collars. There's different brands. Connector is one of my favorites, but PG&E actually makes their own meter collar. I'll show you in a little bit. So a meter collar, instead of how would I put this? Instead of having 16 and 4 kilowatts, so it would be, you can put in about 16 kilowatts. It's 15, pardon me. 15 kilowatts of solar can go into a 100 amp service. I told you before, 4 kilowatts is normal, but if you connect at the meter with a meter collar, now it's 15 kilowatts with 100 amp service. No one puts in a 15 kilowatt system. So this is designed for the maximum of the maximum. I don't want to say no one, but you know, really wealthy people start getting into bigger arrays, and that's not probably all of you. If it is, congratulations. So energy management, this is what I've just shown you here. These are strategies that don't require a smart panel. They just require efficiency. So you might choose a hybrid heat pump dryer, which would use less power than a straight out electric resistance. Or you might put in a heat pump water heater that is a lower power demand. They make them anywhere between 900 watts of power that they need up to 4,500 watts of power. And most people only need a 900 watt powered one. So if you are putting in more powerful devices, a smart panel can manage this. And usually the smart panels have ways of managing your solar and your EV charging and your battery also. So Span, great brand. It comes out of San Diego. EcoFlow, humongous brand coming out of China. It comes paired with all sorts of cool batteries that they're selling. You can go to EcoFlow's website and see. Yeah, I'll show a little bit more later. So smart panel from EcoFlow is just $1,000. Span's about $3,500 plus installation. Span's a small company. EcoFlow is truly a giant in China. So you have economies of scale there. Okay, I'm going to go into energy storage next, having talked about solar and a little, like this is all sort of solar conversation that you're seeing here. That's its intent. Now I'll go into batteries more, but I'm going to load the questions real quick to make sure that people get their stuff. Okay, so all the way gluing, mastic, maintenance costs. Kirk doesn't want a Tesla battery. Where do we find a list of acceptable batteries? Um, it's not so much batteries as the inverters on the batteries. The inverters are what tie directly into the grid, just so you know. So it's not the chemistry of the battery. It's the electronics that convert the chemistry into grid power that PG&E will regulate. So PG&E should have a list, and I don't know exactly where. I think that a solar contractor or battery contractor would have better knowledge of that than myself, and I apologize. I know it exists, but I don't have a link. You are asking this person, Fabrice, Florin. You're asking about your sun power solar and storage system. You want to add more panels and an extra battery. Can you add a different battery like an LG or a Tesla? Or should you reuse the panels and add 2 new batteries that work with it? I don't know. I think that you should talk with a true expert like a solar installer because this gets down into the compatibility of the electronics. Usually LG and Tesla and SunPower are not compatible with each other. So adding more on just breaks the system. But maybe you have a more savvy solar installer than I am that knows better. But that is my take-home wisdom is that you don't get to mix and match, particularly batteries. You can mix and match panels. They're simple. But batteries are like a significant computer tied to a high-end piece of electronics called an inverter. And Betsy, you want me to talk about vehicle to home or grid? And that's towards the end of the presentation, but I have a whole bunch on it. Tom, are there situations where you might be forced to change NEM levels? Yeah, basically, if you go in and try to get a new relationship with PG&E, they'll immediately force you to go to NEM 3. So the system that you have now, well, maybe less size than you want, is definitely the most financially lucrative system that you'll get to install unless we get a new governor or we win some lawsuits or our legislature overturns the governor. So, Lauren and Joan, you want to know about EMF health effects with solar inverters and backup batteries. Maybe 2% of the population seems to be sensitive to actually sensing EMFs. And, lots of animals sense EMFs. Birds, navigate with electromagnetic frequencies. We're 100% surrounded by electromagnetic frequencies from our sun's radio waves at all moments. Like we're just really, we are, the universe is full of EMFs. You think the universe is empty? It's not. The whole thing is full of energy. It's cycling around. That said, if you're sensitive, which is different from there being a health effect. But if you're sensitive, I would recommend putting in gypsum. Sorry, pardon me. Let me think. Not gypsum. Gypsum is normal drywall. I meant to say zinc. Zinc board. Zinc board is what I've seen a friend I have who is a mom who's EMF sensitive. She's put in zinc boards instead of so replacing your drywall with zinc boards that would prevent the EMF signals from the inverters, which is the main one. I wouldn't really think much about the solar panels, but the main one comes from the inverter and the batteries. So if you're sensitive, I don't know of any health effects from EMFs. I just know of people having, and I've read a ton on it. You might know other things, but I do know that some people seem to be able to sense them. What can you use if you live in a condo? There are patio solar arrays made by Legion in the East Bay, I think in Oakland. And you can plug them into a 120-volt outlet, just any old outlet, basically. So you might look at those solar panels. Okay, question. I feel like I should probably dive into a few bit more. Okay, so this is a basic illustration of how batteries work. Okay, so you have your baseline load. Your just solar would take a whole bunch of that load out in the middle of the day, but if you store it, then you can put it up more in the morning and more in the evening when electricity prices are high, etc. Just the basic idea of discharging the battery to make money. So now I'm going to get into types. Yada, very popular with one of my main solar installers, Cal Solar. And Yada it's a 1 kWh battery that sticks to the back of the panel, sort of like the microinverter that sticks to the back of the panels. And these are great because you don't have to find a place to put your battery. It just sits up out there on the roof, or this is a ground mount system that you're looking at. Oh, this is actually a great example of like a school ground mount system, actually. You can see how they're just hammered the poles into the dirt there. So this is 1 kWh for each of the batteries. These are more. So these are Blue Planet, LG, the one that I like, or at least would recommend, Simplify. So DC batteries mean they produce DC electricity that then has to go to an inverter. They don't come with an inverter. So this question of if you're trying to add batteries to a Tesla system, maybe you could go with a DC battery and feed electricity into a battery like the Tesla Powerwall or something like that, because now the Tesla's inverter, which is the thing that pairs with PG&E, the most important thing is that PG&E allow your inverter to add electricity in. Now you'd be using an approved inverter with like a Tesla or Panasonic, a Sonnen, but I don't know that. I do know that Blue Planet, LG, and Simplify, those are a mix and match. That battery then you buy with a different inverter like the Solar Edge that I showed versus Tesla where their inverters are built into their batteries. Now, I'm going to try to encourage you to get a battery. I'm going to compare it against gas. So I'll just go through this real quick, but basically gas generators are very common. They nearly burnt my grandma's house down. They did burn down 1/4 of the downtown of Arcata. Just one generator caught all these historical old wood buildings on fire, and the fire spread the whole city block, and 1/4 of the downtown of the town I live in was shut. It sucked. So size and location. Electric generators are smaller, if you call it electric generator, a battery. The big ones here, they have to go on a cement pad and they have to be far enough away from windows and walls and a whole bunch of things because the heat that comes out of them starts fires. Batteries don't usually, like almost never start fires. Generator fires are common. They're a dime a dozen. You can look them up online, constantly find people who are lighting their houses on fire with generators. Cost, definitely more expensive to get the battery up front. However, you're not allowed to like run a generator into the grid. That's illegal, just so you know, that's not a thing. But you are allowed to run batteries into the grid and actually make money from it. Oh, the cost there, you might see like $9,500 to $13,000 for a nice big old battery and versus a generator, maybe half that cost. Maintenance, batteries generally require no maintenance. Just sit there, maybe dust it every once in a while. Don't put things on it, don't lean things against it, etc. That's just common, leave it alone. It's an expensive thing. It's a piece of electronics. Gas generators, you have to run them every 2 weeks. I mean, in order to, like a professional installed generator, they need to be run to be as part of their maintenance. That sucks. And there's tons of things because it's all moving parts, oils and filters and spark, blah, 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 blah. Cold weather kits if it freezes in your area. So definitely way more maintenance for a generator. Obviously noise. I mean, when people have power outages, you hear neighborhoods when everyone's kicking in their generator after there's a power outage, it's effing deafening. It's right up there with like leaf blower noise versus batteries, which are silent. And there's a picture there on the right-hand side. That is the generator fire that burnt a quarter of the downtown of Arcata a few years ago. Really pissed me off because it shut down Solutions, the place where I go to get my hemp clothing and such. So frustrating. So yeah, electric generators, they don't create any pollution. They have extremely low fire risk. The exact opposite of generators. They're making tons of different kinds of pollution. They're just deadly poisonous. If you have them next to a window, you can kill somebody, right? That's enough carbon monoxide to put them out. Lots of fire risks. Multiple fires sparked during California's preventative power service events from generators. Every year we see those PSPS events causing people to light their houses on fire. And then some considerations, like if you have a gasoline generator, during power outages, gas stations are frequently also not able to pump gas. And so this is a pictures here. This is real ones during our power events where we had like no electricity at this Beacon gas station. Here you can see a couple of kids running across the street because there's also no electricity for the lighting. I mean, gas is not great. However, these generators here, they're not going to cause fires and they're not going to run out of gas or anything like that. They're a solar array, you can be sort of indefinite. You can stop paying attention to the rest of society for a couple of days because you got your system. SunPower, that was mentioned earlier, that unfortunately SunPower is now owned by a different company, but here's their Sun Vaults. Here's the Panasonics. Panasonic, by the way, terrific brand, essentially the leading brand in Japan. Panasonic is, I don't know what it comparable will be, but it's the gold standard there for high quality in Japan. So here are just examples. If you want to roll one up to your house, the Goal Zero Yeti. You can get them with fold-out solar panels or just the battery. Either way, I recommend the solar panels, of course. EcoFlow, I mentioned that brand over in China. There's their EcoFlow Delta Max portable power station with solar panels and batteries. And the batteries have outlets on them and inverters and all the rest of it, so you can go off grid. Bluetti, Jackery, these are global companies. The US State Department had me teaching in Malaysia on behalf of the Biden administration how Malaysia could electrify. And I was delighted to see, I thought, gosh, how am I going to find the products and everything? It's like, oh, these companies are global. There's a Malaysian website for Jackery and Bluetti and EcoFlow. No problems. Here's Anchor. You can find these things pretty inexpensively online these days. You can get them off of Amazon, Now, someone was asking about bidirectional charging, which I love because these batteries I'm showing you, they're like 2 kilowatt hours, 5 kilowatt hours, 10 kilowatt hours. Your car probably has 70 to 130 kilowatt hours in it. And it's your battery on wheels, way bigger than any other battery that you'd ever install in your house. And they can power your house. So the extended range F-150 Lightning has 131 kilowatt hours. So that's equivalent to 10 Tesla Powerwalls, which are 13 kilowatt or 13 and a half kilowatt hours. So 10 Tesla Powerwalls. Most people only install maximum 4 on their walls. That's a rich person who's installing 4 Tesla Powerwalls. So they can charge your whole house if you install kind of a fancy set of inverters and batteries and stuff on your wall, or they can probably power your whole house with their onboard inverter. The onboard inverter is a 30 amp. So it's an inverter that could run your electric dryer, and your electric dryer is probably your house's peak load if you have one. So most likely you could run the entire house without exception just off the inverter that's built into the truck. But you could also, for about $10,000, install a whole bunch of stuff on the wall that then could pull about 25% more power out of the truck. I don't know if it's really worth it, honestly. I think the onboard inverter gets the job done, and PG&E has already approved it for hooking up during power outages. Nissan, they were the first ones to do it after the 2011 earthquake and tsunami in Japan that shut down all the nuclear power plants, not just Fukushima. Every nuclear power plant was shut down. And they didn't turn back on for years. Slowly, they got turned back on. But Nissan, in the meantime, they'd already been selling their Leaf in Japan. Nissan is a Japanese brand, right? And so they started putting out inverter boxes so that you could charge your house. Keep in mind, this is old technology. In the 1990s, my friends were doing this with their electric cars all the way back then, just with off-brand stuff that they were doing themselves. So Nissan in 2011, while being very innovative, it was not like brand new idea or something. So their warranty, I've read the warranty, their warranty today, American Nissan Leafs, you can discharge your car into your house or into the grid many times a day, and the warranty is preserved. You might say, like, well, what about the battery? The amount of electricity that you're putting out into the grid is equivalent to driving maybe 15 miles an hour. It's not a stress on your battery. You're not rolling down the highway. You're discharging a battery at about 9 kW, 9 kilowatts. And when you're going down the highway, you're probably going 30 to 50 kilowatts of power in your car. So this is like school zone driving is what we're talking about. The Nissan Leaf discharging doesn't hurt the battery. Chevrolet's Silverado. Once again, you see they're partnering with SunPower. Everyone is really bummed. SunPower was, the best solar panels. It was an American-owned company. It's a damn shame. So they're putting out their bidirectional charger. That's what they're called. Like you charge in and also you can charge out. There's two different modes, basically. You can charge into your house when the house is off grid. That's kind of easier. But then PG&E is trying to pilot this where they charge it into the grid while the grid is on, like a standard battery and solar system. Everyone's trying to do this. These are all headlines that I just grabbed from the last year. General Motors, Kia, Volvo, Ford, BMW, Honda, Rivian, Mitsubishi, Nissan. I mean, that's essentially all of the cars that are being sold in the United States. Those like GM owns a whole lot of brands. Ford, like they own lots of ones. Chrysler, for instance, this is everyone, and they're all committing by 2026. The thing is that all electric cars today can do it. They just don't have a software upgrade that the companies like. But if you wanted to, you could go buy an off-brand bidirectional charger, plug it into whatever car you want, and pull the energy out. It just would void your warranty. It wouldn't necessarily damage your car, and they don't know that you voided your warranty unless you tell them. So anyway, that's it's an option. I'm not trying to say you should do it. I really do think it'd be best if you waited, but if you don't want to wait, there's one in Arcata, in downtown Arcata, there's a solar installer who has one of these off-brand bidirectional chargers in the window. You can just buy it for a couple grand and walk away with it. So Nuvei is a leading brand. Wallbox is a leading brand, and Enphase, which is everyone uses Enphase microinverters for their solar panels, and now Enphase has gotten into the business of bidirectional chargers, which is awesome. So I'm just showing you, these are brands, Nuvei, Enphase. I mentioned Wallbox, but I don't have an image of this. And I also mentioned how PG&E is encouraging people to do this. So the thing is that they have a target of getting 1,000 cars working as bidirectional chargers. They're paying you $2,500 up front, and they also pay you up to $2,175 for the performance, like actually getting the energy out. And they have a little bit of standards here. Right now, only the F-150 is listed to be able to do this, but Nissan is coming along with that too. So just so you know, like you could do it. PG&E is ready for you. And I think it's important to do this also. Look at the home batteries on the left-hand side. So we did an analysis in June of 2023, and then we did, another same analysis in June of 2024. So in orange is what we saw in 2023. You can see how residential batteries, while tiny, grew. You can see how cars, which were always huge as a battery resource in California, this is a California analysis, all the batteries in California is what you're seeing here. And in 2024 in blue, look at that. Look at the jump. Utility grid batteries, medium-sized, will probably stay that way. People are buying, the whole global market for batteries is car batteries. That's what drives every other battery is car batteries. That is the number one seller planet-wide. And people have said, like, well, will people actually do this? So Honda and the World Resources Institute, they interviewed like a couple thousand people up in Canada. And they found that, yeah, for $500 a year, 2 out of 3 people would do it. And for $1,000 a year, 90% of the people do it. And for no money, half of the people would do it. Just to be nice. Like if the grid needs a little bit of energy, sure, take it. Half the people said that. Don't pay me. One thing you'll see here in the vehicles one, I have 37 miles of daily use. And I'm like, okay, that's not available for the grid. And then 80 miles of reserve range. When they studied this question, they found that people want to be able to at least drive 80 miles. So I'm saying, all right, with daily use out of the way and reserve, we still have more battery in cars than we do in the utility. And if you were to take that battery reserve and such out, which isn't necessarily necessary to have it there, this is more for illustration. Yeah, huge amount of battery. And that's it. That's my presentation. Thank you all. I'm totally ready to dive back into questions.
Hey, Sean, let's
Yes.
take a quick one. Go ahead and take a look at the questions, but I just want to get Lauren
Yeah,
one
I
of
apologize. I don't have a
BC3.
clock here. I'm not even sure if I probably
Oh
blew
no, we're fine.
past
We're
time.
fine.
Okay,
But yeah, I just want to make sure that she gets in her plugs
please.
for her program. And yeah, so Lauren, take it away. Lauren's here with BC3, and they promote the Bay Area SunShares program. I'll just speak oh, I'm on a different screen. We really like promoting SunShares as a county organization because obviously sitting in a government seat, we can't promote one contractor over another, but that's kind of where they come in to vet local contractors and take that kind of off the plate of homeowners for solar and battery projects. So I just wanted to plug that's kind of why we enjoy it from the county perspective and why we like promoting it each year. But Lauren, why don't you go ahead and talk a little bit about more about the program?
Great. Thank you so much, Helen. And Sean, I'll be quick so you can get back
No
to
worries.
Q&A. All right, so let me share my screen. And you can see that, right?
Yep.
Okay, awesome. Hi, everyone. My name is Lauren Vaughn. I'm the Climate Programs Manager at the Business Council on Climate Change, also known as BC3. Before I get started, I'll just say thanks, Helen, for inviting me to speak. I'm super excited to tell you all about the SunShares program and how you can take advantage of some of our clean energy options. So Bay Area SunShares is a solar and storage discount program. What we do at the Business Council on Climate Change is we pool the buying power of all 9 Bay Area counties to negotiate reduced prices for a limited time campaign every fall. So the goal of this program is to make clean energy more accessible and affordable, and also make the Bay Area more sustainable and resilient as a whole. You know, our goal is really to accelerate clean energy adoption across the Bay Area. So all of the residents of the Bay Area's 9 counties are eligible to participate in our program, and then our discount season is this fall, so it actually is open now until November 15th, which is this Friday. Like I mentioned earlier, everyone in the Bay Area is eligible to participate in our program, and this includes these 9 counties. So if you live in any of these counties, you're eligible for the SunShares discount. And then some of the installers that we work with actually provide service outside of these areas. If you're curious, we really encourage you to just sign up and find out. So I'll go into a little bit about the history of SunShares. So Bay Area SunShares has actually been a program of the San Francisco Bay Area since 2012. So it started as a solarized campaign, and then it moved to the city of San Jose, and now it lies with the Business Council on Climate Change. We've run the program since 2016 and installed over 5 megawatts of solar and over 200 battery plus storage units in the Bay Area. So we've helped a lot of people through this process and are always excited to be continuing providing the service across the Bay Area. So a little bit of background on the Business Council on Climate Change. Bay Area SunShares is a program of BC3. So we're a membership-driven nonprofit, which was originally founded by the city and county of San Francisco, and we're dedicated to tackling climate change issues. So we do this through what we call a Learn, Act, and Solve framework, and this helps the Bay Area collectively accelerate meaningful climate action. So SunShares is one of the many programs that we run, and my goal here today is to educate you about the SunShares program and other clean energy options so that you feel like you can make the best decision for you and your home. So now I'll cover how the SunShares program works. There's a couple of different options with SunShares. So we work with 2 to 3 installers each year, and these installers offer rooftop solar installations. So Sean probably covered this, but with solar on your home, you can generate clean energy and offset the costs of your current electricity bill. The installers we work with also offer the option to install both solar panels and home battery storage. So this gets you all the benefits of solar, plus the reassurance that you have power stored in case of an outage. And then finally, if you have solar panels installed on your roof, you have the option to add a battery unit to your existing system. So this now means you can store the energy you've been producing and keep the lights on when the power's out. So why should you go solar with SunShares? There are a few different things that set us apart from other options out there. So with Bay Area SunShares, you know you'll be working with high quality solar installers. We at BC3 do the research of finding a quality installer that we trust. So we selected 2 providers this year through a rigorous RFP process. We've made sure that they're not there to pressure you or rush you through it. They're committed to helping you make the best decision for yourself. And then as part of our evaluation process, we also negotiate significant discounts on quality solar and storage offerings from our installers off their regular pricing. And this helps Bay Area residents get some extra savings on their solar and storage systems. The prices are also turnkey, meaning that they reflect the whole cost of getting solar, from equipment to labor and also permitting. And then finally, with SunShares, you have the opportunity to receive and compare different proposals all in one place. So this way you can get to know your options, you feel like you can make a good decision. This also comes with no commitment necessary. So you can sign up for SunShares and go through the process of having an initial consultation with an installer and getting a custom proposal for your home with no obligation to install. So, if you don't end up signing a contract, there's no kind of penalty. So in order to claim the SunShares discount, you would sign up on our website by filling out a quick form. There's actually only 2 days left to claim the SunShares discount. So the program closes after November 15th, which is this Friday. But in that form, you would choose which installers you want to receive a proposal from. And then those installers will contact you about conducting a home assessment, which can be virtual or a contactless site visit. They'll essentially start the process of designing a solar system proposal for your home and creating a custom proposal. Then you'll receive a proposal from each installer that you selected to hear from, and you have until December 15th to sign that contract and secure that discounted pricing that you saw on your bid. So thank you so much for having me again today. Kellen and I really appreciate it. If you have any questions about SunShares, you can reach out to me. I'll share my email address in the chat, and then I'll also share the sign-up form for the discount. Like I mentioned earlier, SunShares is free. So if you're just curious about solar or want like a quote for your home, the best way to do that is just to sign up through the program and talk to an installer. So thank you so much.
Great. Thanks so much, Lauren. One last plug. I'm going to put our survey in the chat, and we're going to raffle off these solar battery phone chargers. We've been talking a lot about solar battery phone chargers. We have a bunch of them that we can raffle off. So please help us with that survey. It just helps us make improvements. And also, if there's a topic that you want us to, organize a speaker for, let us know in there. And then, we can have more of these with different topics like panel splitting or optimization or, energy efficiency, installation, stuff like that. So I'll pass it back to Sean for Q&A. Thanks again, Lauren, for coming.
Thanks, Lauren. Thanks, Kellen. So anonymous attendee asked, before I upgraded my electrical panel to a 200 amp panel a few years back from a small 100 amp panel, I would not have had the breaker space in the small 100 amp panel to accept solar. Okay, there's a mistake here. The panel that you have has a certain number of spaces in it. You can buy a bigger panel, but still have the same 100 amp service or same 200 amp service. The panel is just a whole bunch of places to put circuits. It is not the power delivered to your house. So you got a 200 amp service and you got some larger panel. It's not a 200 amp panel, it's just a bigger panel. There isn't really a 100 amp panel, there's just panels and they get hooked up to different services. So you say you wouldn't have had the breaker space in the small 100 amp panel, which is just a panel, to accept solar. What you need to do is just put a larger panel, and really you only needed probably one circuit breaker space of additional. You probably could have carefully gone through and combined two of the circuits onto one circuit. If you just looked at it carefully, like, oh, I don't need a circuit for blank. That's fine. You know, like that specific outside light has its own circuit, just stick it on a different circuit. It's just a light. And then you'd have a free space in the box, in the panel box. A different anonymous attendee says, the company that installed our solar panels a few years ago went out of business. If you were to install a battery, do you see any problems arising? Probably not. Like I said, the panels mostly just produce clean electricity, no big drama. And there's lots of different brands of solar panels out there that just produce electricity. So I think you can just install a battery with that solar array without technical issues, at least. Another anonymous person says, but transformer updates and related issues are all going to be resolved by the backmud and getting ready to enforce their gas, water heater, and furnace electrification rules, right? Sure. So I could just say that there really isn't an issue with service upgrades and transformer upgrades. There's an issue with education. Like people don't realize that they don't have to do that there's a half a dozen different strategies for avoiding a service upgrade. I write papers on this stuff. So I showed you a couple of the smart panels, the span panel and the EcoFlow panel. Those are examples of, like, I'm putting in a 60 amp EcoFlow panel right next to a different, for research. I've got span panels that are 60 amps and EcoFlow panels that are 60 amps. That 60 amps with a smart panel can support about 200 amps or more, but at least 200 amps of stuff plugged into it. Even though it's 200 amps of stuff, the way that people actually live is that they'll probably never use more than 30 amps at peak. That's the average. They might get up to 40 amps. Extremely rare, almost impossible to get a house to produce 50 amps of draw unless you have lots of other stuff going on, like arc welders and things. And 99% of people don't use more than 80 amps. And it's a very small tail, thin tail of people from 60 to 80 amps. So, yeah, so I say is that it's at least 99% of people, and I mean that's the actual numbers, like it's 99% of people now don't use more than 100 amps, no matter what their service is. They never go past that. And so yeah, it's not an issue. Backmud can change their standards and it should not have an impact on transformers or wires if you go through, like I said, either power efficient appliances, circuit splitters, smart panels. Those three are easy ones. Chris, you say, is it true that undergrounding lines for ground mounted panels is very expensive? Was told this by a vendor? It depends how far it's running. It's expensive to trench dirt. I mean, all you're doing is digging dirt, right? That's not expensive. You get a ditch witch out there and you dig it. If you were going through your driveway and like a nice concrete patio and all sorts of other things where you're destroying things that aren't dirt, okay, now you're talking about replacement costs or the effort of chiseling through concrete or having to do some sort of underground drill to get your wires. Like, yeah, okay, that's expensive. And that's the expensive thing from the street. If you're underground, your service wire, the blue wire, as I was calling it, the service wire from the street, if you underground that, oh boy, yeah, that's $15,000 to $30,000. But that's because you're ripping up the road and your driveway and the public sidewalk, and it's a fairly long distance. So yeah, ground-mounted panels, if you're not doing much damage to your landscaping and things that you own, is not a particularly expensive way to go. It is still more expensive than hanging it in the air. You could put a pole up and then run the wire just like any other wire, just hang it in the air. That's fine. That's cheap. What do you think of Enphase products such as inverters and batteries? They're a globally dominant brand. Enphase is a gold standard product, and they offer very long warranties on their products, and they've been around for quite a while. I mean, so was SunPower, and they just disappeared overnight. They missed a payment, and all their creditors called their notes, and all of a sudden they were bankrupt overnight. I honestly wish that we'd had the Biden administration come in and intervene and do a bailout of some sort to keep at least one solar manufacturer domestic. They're trying to start new ones with all the Inflation Reduction Act money. Why didn't we keep the one we had? Okay, that's just me being resentful. Anonymous says, how long can I run my house off my EV? Or what can I actually power my house off my EV? Well, I know someone who's run their house for 3 weeks in North Carolina with no power off their car without even recharging it. Now, they're probably using a limited number of loads in that house. I don't know if it's an all-electric house that they're running full blast, but 3 weeks is what they've done with just their car. Anonymous, you said, that's what I meant. I didn't have enough space in my small 100 amp panel, so I had to get a larger panel. Correct. You needed to get a larger panel, but you didn't need to get a 200 amp wire delivered to your larger panel. You just needed a larger panel. And you needed to have a solar array that was fitting on a 100 amp wire, which is 4 kilowatts. Unless you do some other things, like the meter collar that I showed you where you can put in 15 kilowatts. And David Bricks, you say, how much does installation cost for an EcoFlow system? Usually things cost about 3 to 4 times to install as they cost to purchase. So I would guess that if you got a $1,000 EcoFlow panel, that it should cost all in around $4,000 in a normal world where you got a couple bids and that was a reasonable price. And then, okay, so that's all the things that are in Q&A. Now I'm going over to the chat. Fabrice says, kudos to Sean Armstrong for helping promote the Watt diet to help homeowners get, yes, the Watt diet calculator on Redwood Energy's site has shown me how to electrify responsibly with efficient appliances and load sharing practices. Woo-woo! Thank you for putting that link in. Yeah. So Tamra, you say, so would you recommend using your car battery instead of solar? Yes. It's very sincerely, I think that if you drove your car home in the evening, you could power your whole house all night long. And you wouldn't be using any dirty grid electricity because it usually gets dirtier in the evening. And you wouldn't be using any peak electricity chargers because you'd be powering the car into your house. And then you'd wake up in the morning and drive to work and charge your car someplace there. Or maybe charge it in a few days because you've got a big battery. But yeah, like charging it during the day and then powering it at night would be perfect. And you could avoid the cost of the solar array and avoid the cost of the battery and just use your car battery that way and absorb the grid's solar energy because like noontime in California is we had almost 120 days this year in which our grid was 100% renewable for 1 to 4 hours of the day without any fossil fuels in it, not a drop. It's the first time that's happened, but it started happening in March this year. So there are almost every day of the March through October era, the middle of the day is almost completely clean electricity that you could absorb with your car battery and then discharge into the grid in the evening or into your house. Going backward, EV roof damage. John Snell, you say a recent EV with roof damage is a potential source like 64 kilowatt hours of a battery if the floor of the car is not damaged. Please talk about connecting the high voltage output of the battery to the PV array input to a solar arc inverter, which does not need to be grid tied. Okay, well, I have friends who, when there's a power outage, they will take their car and they will charge it into their battery bank. But I'm not an electrician. I don't know exactly how to do that. I apologize. I'm a designer, and I mostly work in apartment complexes. So I'm getting out of my comfort zone and saying how to do it physically. But you're absolutely right. That getting any used EV out there, any of them. I mean, a used EV might be a few $1,000s, like $3,000 or $4,000, but it would still have a 30 kilowatt hour batteries worth of charge in it, like a 2014 Mitsubishi or Nissan Leaf or something like that. And so you're getting a battery, you'd call it 30 kilowatt hours for a moment. That would take 2.5 Tesla Powerwalls. That would cost you 35 grand. I mean, it's 1/10 the cost. Yeah, you're gonna have to put something on the wall to accept the energy, but like you could do it. I just mentioned before, you can get off-brand ones, or you can get at this point, Decibel, DCBEL, Decibel is a real brand out of Canada that's doing this work, where they're doing vehicle to grid charging. And as far as I can tell, it's really the first one that's completely available in the United States, is the Decibel. But yeah, John, you're absolutely right. Go get an old EV, and that is dramatically like 90% cheaper than other ways of getting your battery. Tom, you say most batteries have a 10-year warranty. What is your experience with how often they need to be replaced? The warranty, that's how like inverters started off. We had 10-year warranties, and now microinverters get 25-year warranties. I think that's going to improve over time, but batteries over the course of 10 years might lose 10% of their charge, and that is part of their warranties. They're saying like this is going to be a perfect battery for 10 years, and after 10 years, now it's 90% of a perfect battery or 85% of a perfect battery. So I don't think you should replace them. Not unless you have some like edgy, like you need all of that power. I actually think people should just keep their batteries in place for 20 years, just like the solar panels. Kirk, I have not heard of, I don't know if I can recommend SolarArc. I don't know them very well, and I have not heard of Pites batteries. Okay, I think, oh, you want to link to the Decibel. Fabrice, you say, is there a reliable gadget that would let me do that even if it voids my Tesla warranty? Yes, there are reliable gadgets that would take your energy out of your Tesla car and stick it into your house. And like I mentioned, there's one for sale in the window in the local downtown solar installer company here. I don't know its brand name. I apologize for that. You might be able to follow up if you want to email me, and I can like go downtown and talk with John, the owner of the store. What I'm going to do now is I'm going to change the website over to Decibel so people can see that if they want to do the DC bill. Out of Canada. Okay, stop share. Share screen is a different screen. Here we go. Share, and then here, the aura is what they're calling it. So this is it. This is a bi-directional charger. It also is an inverter for your solar panels up on the roof. It's a DC inverter, so you'd use optimizers, DC optimizers on the solar panels, and then the optimizers would give nice clean electricity to the Decibel on the wall. This thing can also control the battery. It's a smart panel for the house, so it can turn things off if you're going past your peak power demand. It's quite a Swiss Army knife, really, and it's a bi-directional EV charger. And there's a fellow named John Sarter in the Bay Area who sells these. He's the rep.
Well, Sean, I think you went above and beyond with all the great info as always. We're so happy to have you back for this webinar.
Thanks for having me. Yeah.
And yeah, thanks everybody for sticking around a little bit later and coming out this evening. We will be in touch via email with all the slides and everything that we mentioned in the chat. And yeah, until next time, everyone have a great night.
Thanks, y'all. Take care. Thanks, Kellen. Thanks for hosting.
See you, Sean.